Hey everyone! So today we're going to dive into something really cool for leveling up AI. It's called reinforcement fine-tuning, or you'll hear me call it RFT. And it's this fascinating way to teach models not just what they should know, but actually how to think. Think about it. Our large language models are incredible, right? They're like these giant brains packed with facts. But there's a world of difference between just spitting back information and actually using logic to solve a real problem. And bridging that gap, that's exactly what RFT is all about. So to really get a handle on this, we first need to pull apart the two main ways we can improve an AI's performance. They're connected for sure, but they are very different things. Okay, so on one side of the coin, you can improve what the model knows. This usually means things like better prompting or using a technique called retrieval augmented generation, that's RAG, which basically spoon feeds the model more facts. But what happens when the model has all the facts and still can't connect the dots? Well, that's when you have to improve how it reasons. And that, my friends, takes us into the world of fine-tuning. Now, fine-tuning isn't a one-size-fits-all thing. You've got a few different flavors. Supervised tuning, that's awesome for teaching fixed patterns, like making sure the output is always in a specific format. Preference tuning is perfect for nailing style and tone. But RFT is in a league of its own. It's built for those really tough domains where complex reasoning is the whole game. We're talking legal analysis, medical diagnosis, stuff like that. So how in the world does RFT actually teach an AI to reason? Well, it doesn't just rely on simple right or wrong answers. Nope, it uses something way more clever, a grader. The easiest way to think about the grader is like a rubric for an essay. It's a set of rules you create that scores the model's output. So instead of the model just being told that's the right answer, it gets a score. This lets it understand how good its attempt was, which is a much richer signal for learning. And this all happens in a really neat feedback loop. First, the model gives the task a shot. Then, the grader scores that attempt using the rubric you designed. The model takes that score and learns from it, reinforcing the pathways that led to a better result. And it just does this over and over and over again, getting a little bit smarter with every single cycle. This is also why RHFT is so efficient. A single example can provide this huge spectrum of feedback. All right, that's enough theory for now. Let's see how this thing actually works in the real world. Because seeing RFT tackle a genuinely tough problem, that's where it really clicks. So here was the challenge. Take a dense piece of legal text and figure out which of 21 different high-level themes it belongs to. And it could be more than one. This is not something you can solve with a simple keyword search. It requires a deep, nuanced understanding of the text. Just a perfect test for RFT. Now, before a single bit of training happened, the data prep was absolutely crucial. The team focused on quality, not quantity, starting with just 100 really good samples. They also made sure the categories were balanced, so the model couldn't just cheat by guessing the most common answers. And this is a big one. They used actual words like trade instead of numerical IDs. Why? Because models just reason better with meaningful language. So after all of that, the careful data prep, building a custom grader from scratch, did it actually pay off? Let's take a look at the results. Okay, get ready for this because the results are pretty stunning. On the left, you see the performance of a massive frontier model, GPT-4. In the middle, that's the base model they started with. And all the way on the right, that's their model after RLHT. It didn't just get better than its old self, it actually leapfrogged GPT-4 on this specific specialized task. This just goes to show you the power of teaching a smaller model to reason like a true expert. And hey, this wasn't some one-off fluke. The platform accordance used RFT and saw their performance jump by over 40% on a major industry benchmark. This stuff delivers real, measurable value out in the wild. Okay, let's bring it all home and distill this down to the key takeaways. If you're thinking about using RFT, what are the absolute must-knows? David from Accordance really nailed it with this quote. Your grader can't just be a binary right or wrong. It needs to be continuous, meaning it can give a whole range of scores. And it has to be stratifying, which is just a fancy way of saying it can clearly tell the difference between a great answer, a good answer, and a bad one. An answer that's 80% of the way there should get more credit than one that's only 60% there. That's how the model really learns to improve. So here's your final cheat sheet. Number 1, start with a small set of high-quality data. 2, design a smart, continuous grader that rewards progress.
3. Benchmark your base model first so you actually know if you're making things better. And finally, be ready to iterate. Tweaking your grader and your prompts is how you're going to unlock those amazing results.
Look, RFT really opens up the door to automating tasks that once seemed way too nuanced or complex for an AI. It's all about teaching these models to think more like we do, more like domain experts. So the real question I want to leave you with is this: what high-level reasoning challenge are you going to solve next?